Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us continue discussing the last submodule of this chapter about general requirements. I am your professor, Dr. A.P. Zantua. I am a civil engineer, electrical engineer, mechanical engineer, industrial engineer, and an alumni of BSME, Polytechnic University, Japan, as a Japan government scholar. So let us start with the objective of the code, wherein it states that the life safety code addresses specific requirements to minimize danger to life from fire, smoke, heat, and toxic gases. In doing so, we also provide mission continuity and property protection of both new installation and existing buildings. There are three major topics in this part 2 about general requirements. We will have Code SPA, Occupancy Classification, and Hazards of Contents. In this particular module, we are in Code SPA, and under which we have the scope, purpose, application, which are the words that have the acronym SPA. And the last submodule we already discussed to explain the concept of equivalency. And in this module, we will tackle the general code provisions. What are the general code provisions? Chapter 4 contains general code provisions not covered in the administrative provisions of Chapter 1. And that is the difference. So we have administration in Chapter 1, and now we have references in Chapter 2. We have what? We have the definitions in Chapter 3, and now Chapter 4, we have general code provisions, wherein goals, objectives, and assumptions are explained among with the other subtopics. Some of these general provisions in Chapter 1 are listed here. We will go through this list in details. Okay. So, as you can see, the contents of Chapter 4, aside from goals and objectives, we have what? The existence of prescriptive and performance-based options. So as a designer, we have the option to show the owner that we have prescriptive and performance. But again, in our country, almost always prescriptive. So meaning, the easiest meaning of prescriptive-based option is that we are just going to comply with the written provision of the code. That is the substantial meaning. However, in performance-based option, usually we are presenting a solution which are already happened, experienced in the past, which are documented, wherein it may not be in the code, but it could be used as a design basing on the actual use and historical application. Okay, for example, you already had a design that was used in the previous years ago. How many years ago? For example, 15 years ago, 30 years ago. And already found out by performance analysis that they are what? they are working properly well. Okay? Meaning they are protecting the lives of occupants, okay, from fire. So that could be a basis, but those things must be documented. Okay? But again, in a country, the reasoning, the justification are what? Not in actual, but still in the design. For example, they are using what? Analytical tools. They are using analytical tools, design tools, simulation. They are simulation is good when there is no other available actual data. However, there is no substitute for actual. That is what we learned in Japan. It's a Japan engineer. While in our country, we are focusing on justification, justifying the design, even though there is no actual testing. There's no actual design construction that later on tested in real setting. Okay? Only what? Simulation. And the simulation justification is not even prototype. The simulation is not even prototype. The simulation is what? Software. Software simulation. How could a software simulation be an important justification for the purpose of actual implementation of engineering design? Okay, that is very dangerous. For simulation in software could be used for what? Scientific study, research, but not in actual application wherein there are real people, there are real persons, there are human beings occupying the buildings that could suffer in what? In error, mistake of the application of the software. So maybe you are doing it properly, you are designing it properly, you are using that computer software properly. However, there are condition, assumption used in designing and utilization of the software that may be different in actual, in reality, in the factors on the ground. And so that might be helpful in bringing about the awareness to these things in our country. But however, that forms part of the tradition of the engineers making the design in this country. And very good example of performance-based design are those in Japanese installation. Okay? Japan is using performance-based design rather than prescriptive type. Okay? And also in this chapter 4, authority having jurisdiction will be explained deeply. Inspection, maintenance, and testing will also be a contention of discussion in this chapter. Very important because not only the designer must be held accountable, but also the inspector, the maintenance people, the testing engineer or technician. Okay? Okay, so again, next would be features, obviously the public. Okay, not only obviously the public, but they increase the confidence of the occupants to use that structure, to use that building. Okay? Also, this chapter involves fire drills and emergency action plans. Okay, so more on what procedure that must be in place, procedure that are being done already in the future and being improved year by year. Okay. What is now the tradition of fire drills in our country? You cannot say that we have a tradition of fire drills in our country. Okay, it's not yet done in our country. Fire drills and everything done once every 3 years, every 5 years. That's not the way to do it in real life. If we want something to be what our system to be safe for our occupants. And let us start with the goals, objectives, and assumptions. Goals of this code is to protect occupants not intimate with the initial fire development. Meaning, intimate meaning in contact or within the vicinity of fire. So we should be able to immediately separate those people that are really far from the fire. What happened if there is a fire and the panicking public are going into the fire itself, not going away or not escaping because of what? For example, confusion or yes, panic. Okay. So one of the goals must not that situation happen. So we have to protect occupants, and those are not intimate with it from the cause of fire damage, injury, or fatalities. Another one is improvement of the survivability of occupants intimate with the initial fire development. So there are two types of person that we have to take care of because we want to have a safe occupants. So those occupants which are not intimate and those occupants which are intimate. Those occupants which are intimate must survive. Okay, this initial fire development. So what do you mean by initial fire development? So excuse me. Let us we mean initial fire development is depends on the design. 30 minutes, 1 hour, 2 hours. Depends on the design that the designer and the owner proposes to the ASJ and afterwards approved by the ASJ. Okay? So it could be, but those initial time fire development must be approved by the ASJ. There are set minimum. I think it depends on the city. Right? Depends on city or municipality. They are what? Because why it is dependent on city or municipality? Because there are different capabilities in different situations, cities to cities. There are cities with so many high-rise building that are what? Side by side with each other. There are cities that are usually low, medium-rise building. And there are cities with so many neighboring cities that could help. For example, in utilization of what? Fire truck. And there are cities with far availability or accessibility from source of water. Okay? There are provision for what? For water supply, but it will only what? Good for how many minutes? Okay? Because, for example, they are located in higher grounds or near the mountains, okay, near the mountainous steeps. Okay, so they are dependent on the assessment of the AHJ, and also how fast the fire trucks, the firefighters, would be able to respond. Okay, so and how many are the occupants in the area? So there are several that have to be considered. So let us not deal with that, because those are the factors that are being dealt with by the authorities, AHJ, okay, or the what, building officials. Okay? And also we have to explain the assumptions. There are single fire source, there are multiple fire source. What are the assumptions that are used in this system, this design? Excuse. Based on hazards associated with fire and other events that have comparable impact on a building and its occupants. Another type of assumption. Because it is very hard to predict. Okay, you can only what? Analyze what type of hazard and level or degree of hazard are there in at the beginning, but as the building is being used and utilized by different occupants, cannot sometimes control. Okay, so is maybe your design maybe is not bearing away and away with too much different, gradually growing difference from the design assumption. And if you are dealing with prescriptive based options, you have to look into chapters 1 to 4, 6 to 11, and 43. Those are the core chapters. As we already know by now, applicable occupancy chapters are 12 to 42. While if you are dealing with performance-based option, you can be guided by chapters 1 to is it chapter 5? I think you can do chapters 1 to 4, but performance-based option is chapter 5. Okay. Okay. There's something wrong with this. So there's what? Cut and paste. So this must be chapter 5. Now, what do you mean really by authority having jurisdiction, or AHJ? It is the person or office. It can be an office, not a single person, because in our country, there are several of this person. That's why we are collectively calling this group of persons to be an office of AHJ, or Office of Building Official. Okay? There may be multiple AHJ for one project. And that is true in our country. That's true in our country, particularly different discipline. HG for mechanical, HG for electrical, HG for civil, HG for structural, HG for building design, HG for sanitary, HG for electronics. So those are HG for building plan in our country. So there are so many of these, and they are related to fire, and there is a separate law that governs fire code in our country, different from those engineering discipline law, specific for those mentioned engineering disciplines. Inspection, maintenance, and testing are required. All required items must be continuously maintained. After installation, there is an inspection, then we will now operate the building, and maintenance must continue. And yearly inspection is required. Yearly inspections are required. Okay. If there are what additional or so that we could gauge after how many years we have to really modify our system. If our system is not answerable or is not on the right minimum degree, okay, so we have to what? To modify the fire protection system. And for example, subsection 4.6.12 describes the requirement for maintenance specifically. Right? Maintenance of what? For example, that one, emergency light. Okay, so types of emergency, our power supply may trip, may be out of use. Okay, so that is a requirement. Features obvious to the public. Those are maybe not required by code, but obvious to the public. Okay, must be maintained or removed. Okay, so there are growing number of visitors or occupants that observe something, even though they are not particularly written in the code and not required by the code. Okay, but the feeling of the occupants suggest, okay, that they do not have confidence using the building in that condition. So we need to add features that would satisfy their their visual, their impression of what is a safe place to walk in. Okay? So and that features must also be maintained and removed if they are contrary to the objective, which is to minimize damage to life. Okay? Fire drills and emergency action plans. So in other countries, there are religious periodic drills that are being conducted and supervised by HJ. Okay? We are written in the occupancy chapter. So there are different realities on the ground with respect to the occupancy type of the structure. Design in cooperation with local authorities. So it is a good idea to have a drill, emergency action plan, and design of this procedure in consultation with local authorities. And example, we have what? Existing buildings. So, research and for example, actual documented application. All existing building must meet as a minimum threshold the requirement for existing occupancies. So minimum requirement for existing. Okay. Chapter 43. Chapter 43 is what? Modification. Addition. Okay, so repair, restoration, okay, addition, modification. That is chapter 43. The reconstruction, okay. Then there are requirements. So usually the entry point of new requirements are from research. Research that are what? Scientific, done by those experts, and they contributed for the purpose of updating the code and finally publishing a new version of the code. Okay? So that is the trigger point for having the code being replaced or being given another version, updated version. Okay. So research and minimum. For example, as I mentioned, chapter 43 is for building rehabilitation in general, which involves repair, renovation, reconstruction. Those are the 3 R's. And also modification, okay, modification, change of use, change of occupancy, okay, and addition. So there are how many? There are 7, no? 7 types of rehabilitation work. There are categories, no? So there are 3 R's, and what are the 3 R's? Repair, renovation, reconstruction. We have modification, change of use, change of occupancy, and addition. What is repair? It is patching, restoration, or painting of materials. Very important, just painting, because paint is actually flammable. Okay, so paint could be an added fire hazard. That's why it is important and is being included and defined in this way. Materials, elements, equipment, or fixtures for the purpose of maintaining such materials, elements, equipment, or fixtures in good or sound condition. Okay. What do we mean by renovation? It is the replacement in kind, strengthening, or upgrading of building. So in repair, we are not doing anything in the general shape or plan of the building. Renovation, we are replacing in kind, okay, or strengthening. So we are adding something in order to putting up. So we are changing Okay, so in repair, we are, for example, changing those components that are not really essential. Okay, they add up to the beauty, to the aesthetics, like painting, but it's not really essential for the building to stand up. Okay, from the engineering point of view. Okay, and in renovation, upgrading of building elements, material. For example, there are new materials available that are better. Okay, so we have to replace fixture that does not result in a configuration of the building. So this would also not result in reconfiguration of building or those spaces. So the floor plan are what? Floor plans, first floor, second floor, third floor, and so on, are still there intact, same manner. Okay, but the replacement is in the form of kind and strengthening. Okay, so essentially the same shape, just like in repair. Okay, same functionality. Okay, it's like in repair. But in repair, we are what? Not replacing the kind. Okay, repairing, we are, for example, we have to replace a component of a machine. We will just buy the same part and replace it with new one. Okay, not in renovation is, for example, we have a part that failed. We will buy a replacement that is better or a different brand that we know is a new version. Okay, so the kind, it has extra strength, for example. Okay. How about modification? The reconfiguration, we will now reconfigure the space. For example, we change the layout, floor plan, or the number of doors, or the presence or absence of doors, okay, or windows. Okay, addition or elimination of load-bearing elements. Okay, so meaning columns and beams, so on. No? So addition of that or elimination of that forms part of modification. We are essentially changing the layout. We are reconfiguring the space. Okay, for the installation of any additional equipment. Okay. Previously, there is none. Now, we will put up another equipment. What is reconstruction? The reconfiguration of a space that affects an exit or a corridor shared by more than one occupant space. So this is the difference between modification and reconstruction. You also have the same reconfiguration of space, but this time, this affects the exit or a corridor shared by more occupants. Okay? Or the reconfiguration of space such that the rehabilitation of more area is not permitted to be occupied because existing means of egress and fire protection system or their equivalent are not in place or continuously maintained. Okay, so we need reconstruction. Okay, I will repeat: reconfiguration of the space such that the rehab work area is not permitted to be occupied because existing means and fire protection system or their equivalent are not in place or continuously maintained. Take note of the use of the word equivalent, their equivalent. So that is a concept of equivalency. Right? If they are not in place or continuously maintained, so we can what? Reconstruct. Okay, which would affect shared or common occupant space. Okay, so that is reconstruction rather than modification. Change of use. Change in the purpose or level of activity within a structure that involves change in application of the requirements of the code. Definitely, it would change. Okay? Change of use. How about change of occupancy classification? What is the difference between change of use and occupancy? The change in occupancy classification of a structure or portion of structure. Okay? They are different because change of use is a change in purpose or level of activity. Okay? And the purpose may mean within the same type of occupancy, and therefore the occupancy classification will not change, but the purpose change. Okay? For example, level of activity, the volume or the movement, the volume of movement of occupants. Okay? That is change of use. Addition, what it is an increase in building area, aggregate floor area, building height, or number of stories of a structure. Very easy. Addition is very easy to define. There is an additional area, space, or additional story, 3-story, 4-story. Okay, so then the 4-story building will become 5-story building. So that is addition of the story and height to building. So this is this could be easily observed by the public or not just the expert. Expert meaning those maintenance people, they are engineers, they are a group of people from that department. They know what are the new, renovated, modified, because they know they have the details, but those cannot be directly observable by the public. Okay. However, addition could be observed directly by the public. Okay. Addition of story, addition of working area, okay. Addition of building height. Okay. So that is our last slide for this whole module number 6. Okay, again, this is Dr. DrEYPEI, preaching engineering for nation building.